Hello everyone, welcome back to my channel Problematical. Today we'll continue with Polynomials Chapter 2 of Class 10th Maths ncert. Exercise 2.4 is an optional exercise. However, we will complete every question there is to complete in the chapter in the book of ncert. The first question is, verify that the numbers given alongside of the cubic polynomial below are their zeros. Also verify the relationship between zeros and coefficients in each case. So let's do the first part. First, verify that the numbers given alongside the cubic polynomial. So this is a cubic polynomial 2x cubed plus x squared minus 5x plus 2. And the numbers alongside, you have to show whether they are the zeros or not. So if I place the value of x as 1 by 2, and if I get p of 1 by 2 is equals to 0, then this particular 1 by 2 is the ZER of 0 of p of x. Let's start with it. When x is equals to 1 by 2, p of 1 by 2. You're calculating p of 1 by 2 means everywhere in place of x, you're placing the numerical value 1 by 2. This is 2 into 1 upon 8 plus 1 upon 4 minus 5 upon 2 plus 2. This is 1 half. Half minus 5 by 2 is minus 4 upon 2 plus 2, which is equals to 0. So p of 1 by 2 is 0. This is what you got. Next. Now you will try for the other values. Next value is when x is equals to 1. P of 1 is equals to 2x cubed plus 1, in place of x you're supposed to place 1. 2 into 1 cube plus 1 square minus 5 into 1 plus 2. Which is 2 plus 1 minus 5 plus 2. 2 plus 2 plus 1 is 5. 5 minus 5 is 0. Here 1 is also 0. When x is equals to minus 2. P of minus 2 is equals to 2 into minus 2 to the power 3 plus minus 2 square minus 5 into minus 2 plus 2. This is 2 into minus 8 plus 4 plus 10 plus 2. This is minus 16 plus 16 is equals to 0. So by observation, we got all the three values to be equal to 0. So we can easily say that 1 by 2, 1 and minus 2 are all three are ZER zeros of the given polynomial p of x. Therefore, one by 2, 1 and minus 2 are the zeros of the given of p of x. And what is p of x? I'm rewriting it. 2x cubed plus x squared minus 5x plus 2. Now, second part of the question says, verify that the relationship between zeros and coefficients, in each case. So, in polynomials, we represent, in polynomials, we represent zeros by alpha, beta, and gamma, delta, respectively, depending on the number of zeros. This is a cubic polynomial. It will have 3 zeros, 3 distinct values, 3 values of x, may or may not be distinct. So let us denote them by alpha, beta, and gamma. What are coefficients? Let's write the general form over here. General form of cubic polynomial. This is ax cubed plus bx squared plus cx plus d. So is the coefficient of x cubed, b is the coefficient of x squared, c is the coefficient of x, and d is the constant term or coefficient of x to the power 0. So your coefficients are a, b, c, and d. Now, there are three terminologies over here, three relationships between zeros and coefficients that you verify. First is sum of zeros. Sum of zeros is alpha plus beta plus gamma. Okay. And this value should be equals to minus b upon a. That means minus coefficient of x square upon coefficient of x cube. Minus coefficient of x square upon coefficient of x cube. Second is the sum of product of zeros taken two at a time. That means you're adding certain things. You're adding certain things. Sum of product of zeros. In these terms, you're taking product of zeros taken two at a time. So two products, alpha beta, beta gamma, and gamma alpha. This is said to be sum of product of zeros taken two at a time. So let us write it over here. Is equals to alpha beta plus beta gamma plus gamma alpha. This value is equals to c upon a. C is the coefficient of x upon coefficient of x cube. The third relation is product of zeros. Product of zeros is equals to alpha beta gamma, which is equals to d upon a, sorry, minus d upon a, which is equals to minus constant term upon coefficient of x cube. Now, these are the relationships that we are supposed to prove. That means we have to check for our given values whether your LHS is equals to RHS or not. What is your LHS in the first statement? This is LHS, alpha plus beta plus gamma, and this is your LHS, this is your RHS. Second equation, this is your LHS, this should be your RHS. Third equation, this is your LHS and this is your RHS. Okay, three equations to be proved. Now let's understand what are the values of alpha, beta, gamma and capital A, capital B, capital C for the given values. Comparing these two equations. First and second. Comparing P of x and general formula. Comparing or equating 1 and 2. We get capital A is equals to 2, capital B is equals to 1, and capital C is equals to minus 5. Capital D is equals to 2. So you got the values of capital A, capital B, capital C, capital D. Now alpha, beta, gamma are zeros. It's already proven from here that they are zeros. From 3, we have alpha is equals to 1 by 2, beta is equals to 1, and gamma is equals to minus 2. So you've got these values. Now let's consider equation 1. Equation 1, LHS is equals to alpha plus beta plus gamma. Let's substitute the values of alpha, beta, and gamma. So alpha, beta, gamma is 1 by 2 plus 1 minus 2, which is 3 by 2 minus 2, which should be equal to minus 1 by 2. Now if you observe minus 1 by 2, your answer should be equal to minus b upon a. So let's take minus sign aside. This 1 by observation, it can be written as b. And this 2 by observation can be written as 2 and can be written as A. This is equation first. Let's write Roman numbers. Equation 1. The second equation is alpha beta plus beta gamma plus gamma alpha. What we are doing is we are checking whether LHS equals to RHS or not. So LHS में values put करेंगे और देखेंगे RHS आता है. 1 by 2 into 1 plus beta gamma is 1 into minus 2 plus 1 by 2 into minus 2. This is half into 1 is half minus 2 plus 1. Okay. What would be this value? Here you should have minus 1 because this minus sign is also there. So this is minus 1. This is 1 by 2 minus 3, which is equals to minus 5.2. Now by observation, minus 5 is C. So you can easily write this C and 2 is A, which is the required RHS for this particular second equation. Next, product of zeros. Alpha beta gamma is equals to 1 by 2 into 1 into minus 2. 2 gets cancelled with 2 and you're left with minus 1. Now, this minus 1 can be written as minus 2 upon 2. Why are we writing in this part? Because we want the answer to be D upon A and D's value is 2 minus D in the numerator. Minus sign is already there. So instead of 1, if you want 2, you'll have to multiply divide by 2. This is minus, instead of 2 you can write D, instead of A you can write D. We know what we want. All we have to do is show. Verify is to let the evaluator see that yes, you do understand the concepts. Yes, the values that you've placed will lead you to the result on the RHS. So from 1, this is your second equation and this is your third equation. Okay, so you can easily say from 1, 2 and 3 relation between zeros and coefficients of cubic polynomial is verified. If you do not have time, instead of writing the whole statement, you can write hence verified, but it's always recommended to write a complete statement and have a balanced presentation in anything you write. Second question. In the second question, you have to do the same thing, but now the values of p of x and x are changed. P of x is x cubed minus 4x squared plus 5x minus 2, and your values are 2, 1, 1. So in the second case, p of x is given as x cubed minus 4x squared plus 5x minus 2, and you have to show that 2, 1 and 1 are zeros of p of x. This is the first part of your problem. So again, we'll substitute the values. Let when x is equals to 2, and x is equals to 2, p of 2 will be equal to 2 cube minus 4 into 2 square plus 5 into 2 minus 2. Solving this, you get 8 minus 4 into 4 plus 10 minus 2. So 4, 4, 16 minus 16 plus 10 minus 6 minus 6 minus 2 minus 8, and 8 minus 8 is 0. So you got p of 2 is 0 when x is equals to 2. P of 1. P of 1 is equals to 1 cube minus 4 into 1 square plus 5 into 1 minus 2. So this is 1 minus 4 plus 5 minus 2. Minus 4 minus 2 minus 6. 1 plus 5, 6. 6 minus 6, 0. The last value is also 1. So you've already proven for x is equal to 1 to get P of 1 is 0. So you need not write this third part again. Therefore, 2, 1 and 1 are zeros of P of x. From 1 and 2. Now in the next part, what you're supposed to do is supposed to verify the relationship between zeros and coefficients. So let's calculate the coefficients first. What are the coefficients? General form. General form of cubic polynomial is ax cubed plus bx squared plus cx plus d, equating or comparing this with P of x. We need not write about this. Equating with P of x to get a is equals to 1, comparing this with this. X square coefficient minus 4, here you have 3, here you have b, so b value will be equal to minus 4. C is equals to 5 and d is equals to minus 2. Now first is sum of zeros. So sum of zeros is equals to alpha plus beta plus gamma. Okay. Therefore 2, 1, 1 are the zeros. Let alpha is equals to 2, beta is equals to 1 and gamma is equals to 1. I've given them variables here itself. So now you'll substitute these values, 2 plus 1 plus 1, which is equals to 4. Okay. In this form, this 4 can be written as minus of minus 4 divided by 1. Now this minus 4 is b. So it is minus b upon 1 is e, which is your RHS. So this is your equation 1. Second, sum of product of zeros taken 2 at a time. This is equals to alpha beta plus beta gamma plus gamma alpha, which values, now substituting these values, you get 2 into 1 plus 1 into 1 plus 1 into 2, which is 2 plus 1 plus 2, which is equals to 5. 5 can be written as 5 upon 1, which is equals to c upon a, equation 2. In third equation, you have product of zeros. This product of zeros is alpha, beta, gamma. This is 2 into 1 into 1, which is equals to 2. Now, this 2 can be written as minus of minus 2 upon 1, minus of minus 2 upon 1, which is equals to minus d upon a. This is your equation 3. From 1, 2 and 3, relation, you can write the whole thing, relation between coefficients and zeros is verified. Next question. The first question had only 2 parts. Next question. Find a cubic polynomial with sum product of zeros of its good product of sum of product of its zeros taken two at a time, and product of its zeros are as 2, -7 and -14 respectively. So what values are given to you? Three values are given to you. What does these three values denote or represent? The first value is, the first value is sum. You have to find the cubic polynomial. Now your job is to find the value of p of x. P of x is equals to question mark. You're given sum, comma. So the first value is sum. It's respectively written over here. So sum, which is 2. Sum of products of its zeros taken two at a time is -7, and product of zeros is -14. It's given that alpha plus beta plus gamma, so sum of zeros is 2, first value. Product of zeros taken two at a time. Sum of product of zeros taken two at a time, which means alpha beta plus beta gamma plus gamma alpha is equals to -7, second value. And product of zeros alpha beta gamma is equals to -14. Now you have to find the cubic polynomial. So again, there are two methods to do it with. One with the help of a formula, and another with the help of basic understanding and basic small formulas of these three, a relationship between zeros and coefficients. We know that alpha plus beta plus gamma is equals to minus b upon a. So given value is 2. 2 is equals to minus b upon a, which means you can easily write b is equals to -2. Alpha beta plus beta gamma plus gamma alpha is equals to c upon a, second formula or second relation between coefficients and zeros. This complete value is -7, whose value will be equal to c upon a. You can write c is equals to -7. Also, alpha beta gamma is equals to minus b upon a. Given value is -14 is equals to d minus d upon a, which means d is equals to 14a. So these are the three equations that you got. 1, 2, and 3. We know that the general form of a cubic polynomial in general is written as ax cubed plus bx squared plus cx plus d. Here all the three values b, c and d are dependent on a. So we assume that a is equals to some constant. We can have a variable or a constant, and using small key, we can hold any value. So let a is equals to t, you get b is equals to -2k, c is equals to -7k, and d is equals to 14k. Substituting these values in the general form, we get kx cubed plus minus 2kx square minus 7kx plus 14k. You can take k common. You're left with x cubed minus 2x square minus 7x plus 14. Now this is a general form of cubic polynomial formed if you assume these values. You can also solve the same question using a formula. The formula so states. Let's solve it with the help of the formula as well. Alternatively. Alternatively means your answer is, this is your answer in the first step, but the same answer can be attained using another method. It's a formula. The formula states that the cubic polynomial is equals to x cubed minus alpha plus beta plus gamma which is sum of zeros into x square plus sum of product of zeros taken 2 at a time into x minus product of zeros alpha, beta, gamma. If you substitute the given values over here, you get, and this has to be multiplied with k in a general form. So k multiplied by x cube minus this value given is 2. So 2x square plus of minus 7 plus this value is minus 7 into x. So instead of writing it like this, we merge them. Plus minus will be minus. You can write minus 7x minus 7x minus alpha, beta, gamma is minus 14. So minus minus becomes plus 14. So by observing, you get the same result. In both the scenarios, you get the same result by using a formula, simple formula, and the values were placed, or by using 3 distinct formulas or relationships between zeros and coefficients and then coming up with the same result. Next, your third question is, if the zeros of the given polynomial is p of x are a minus b, small a, and a plus b, find a and b. A and b are variables and they are your zeros. That means you have taken certain variables a and b and you've represented your zeros in terms of those variables. So what is given to you? Your zeros. Let's say alpha, beta, gamma are the variables that I'm choosing for zeros. So given values is alpha is equals to a minus b, beta is equals to a, and gamma is equals to a plus b. So what do we have over here? We have a polynomial that is given to us, right? So let's write the general form of the polynomial. In general form, you know that we have ax cubed plus bx square plus cx plus d. Equating these two, equating general form with p of x, we get a is equals to 1, b is equals to minus 3, c is equals to 1, and d is equals to 1. Now, what does this mean? Zeros are given to you, coefficients are given to you. These are coefficients of your polynomial. We know the relationship between zeros and coefficients. Let's write the first equation. Alpha plus beta plus gamma is equals to minus b upon a. Let's substitute the values. Alpha value is a minus b, beta value is a, gamma is a plus b. This value should be equal to minus b upon a. Minus of b value is minus 3 upon a is 1. So this gets cancelled. You get 3a is equals to 3. A is equals to 1. You got the value of a as 1. Okay. So b value came round to be 1 from here. Your alpha got reduced to minus b and your gamma got reduced to b. How will we use this? Write the second equation. The second equation states that alpha beta plus beta gamma plus gamma alpha is equals to plus c upon a. C upon a. Substitute the values. Alpha is minus b, beta is 1, beta is 1, gamma is b, gamma is b, and alpha is minus b. Is equals to c value is 1 upon a value is 1. So what do we have? Minus b plus b minus b square is equals to 1. These two get cancelled and b square is equals to minus 1. Now this is difficult to solve because we've never seen a square whose value comes down to be minus 1, right? So let's try this third equation on it. Third equation states that your alpha, beta, gamma should be equal to minus d upon a. Alpha, beta, gamma is multiplication of the 3. So minus b into 1 into b should be equal to minus b value is 1 upon 1. So minus b square should be equal to 1. Which means b square is equals to 1. If you get b square is equals to 1, what should you have? Let's recheck. Yeah, sorry, this is completely wrong. When you substitute this as 1, you get 2 terms, not a single term. It's a very simple, silly mistake. So when a is equals to 1, you place it over here, you'll get 1 minus b. A is equals to 1, and you'll get 1 plus b. Now it's correct. If you consider the second equation, it will be very lengthy. So we'll directly skip to the third equation, alpha, beta, gamma. You can try solving by the second equation, and I hope you get it. So alpha, beta, gamma is equals to minus b upon a. Alpha is 1 minus b, beta is 1, and gamma is 1 plus b. Is equals to d value is minus 1 upon 1, which is equals to minus 1. Multiplying this, you get 1 square minus b square is equals to minus 1. Now it looks right. This is minus b square is equals to minus 1 into minus 1 because this k square will go on the right hand side. Minus b square is equals to minus 2 implies b square is equals to 2, which means b is equals to plus minus root 2. You will have to write plus minus from here onwards whenever you take a square root. So you got two values of b, plus root 2 and minus root 2. So you have to find the values of a and b. Those are the values of a and b. Your a is equals to 1 and your b is equals to plus minus root 2. So that's your answer. Next question. If two zeros of the polynomial, this one, are given to you, find the other zeros. Now this looks like something of a problem that we encountered in the last exercise, but the roots given here are inserts, or they are a combination of rational and irrational numbers. 2 is a rational number, root 3 is an irrational number. So what is given to you? P of x, a polynomial, is given to you. We've written the polynomial. Next, two roots are given to you. So two roots or zeros given to you are 2 plus minus root 3. When you say 2 plus minus root 3, it means 2 plus root 3 is one root and 2 minus root 3 is another root. So two roots are given to you. Now the degree over here, maximum power of x is equals to 4. So this is a biquadratic polynomial. You can write p of x is biquadratic in nature. P of x is biquadratic. Since degree of p of x is equals to 4. Maximum power of x is 4 in the equation in any of the terms. Therefore, p of x will have 4 zeros. Now, out of these 4 zeros, 2 zeros are given to you. 2 of these zeros are 2 plus minus root 3. So you can represent p of x as x minus alpha, first, x minus beta, x minus gamma, and x minus delta. Two are given to you. So alpha and beta values are given to you, right? Alpha x is equals to, so x minus 2 minus root 3, and this is x minus 2 plus root 3. These two values, two zeros are given to you. You placed alpha is equals to 2 plus root 3, and then you placed beta is equals to 2 minus root 3. Now, the rest two values are x minus gamma, x minus delta. Let's understand that here you have two linear expressions. If you multiply them, you get a quadratic polynomial. Let's represent this quadratic polynomial by g of x. So, p of x. Now, here if you observe this one value and this one value, it looks something like a minus b and a plus b. So the answer can be written as a square minus b square. That's why p of x is equals to a square. A square means x minus 2 whole square minus b square is root 3 whole square, which is equals to 3 into g of x. Let's take this on the left hand side. On the right hand side, it is multiplied with g of x. On the left hand side, it will be divided by p of x. So p of x divided by, let's expand this, x square minus 4x plus 2, plus 4, sorry, minus 3 is equals to g of x, which implies, placing the value of p of x over here, x to the power 4, let's change the value. X to the power 4 minus 6x cubed minus 26x squared plus 138x minus 35. The whole p of x is to be divided by, let's merge these two, x square minus 4x plus 1, and the result should be equal to g of x. G of x is a quadratic polynomial. It will lead you to using middle term splitting method, you can get the values of gamma and delta, which are the required zeros. Now let's divide them in a polynomial form. By the general, let's divide it using the general division method. X to the power 4 minus 6x cubed minus 26x squared plus 138x minus 35. So p of x, we've taken p of x divided by x square minus 4x plus 1. X square minus 4x plus 1. Using our basic method, first term divided by first term, so x to the power 4 divided by x square, you'll get x square. Okay, now this x square is placed over here, then x square multiplies the whole g of x. X square into x square is x to the power 4 minus 4x cubed plus x square. Subtraction, sign change. Cancellation, you're left with minus 6x cubed plus 4x cubed, which is minus 2x cubed, minus 26x square minus x square. What does this give you? Minus 27x square. Rest of the terms as it is. First term minus 2x cubed divided by first term x square. You're left with minus 2x first term divided by first term. Okay, minus 2x. This minus 2x is to be written over here. Then multiply minus 2x with g of x. You get minus 2x cubed minus minus plus 4 2s are 8, so 8x squared. Then minus 2x. Subtraction, sign change, cancellation, minus 27x squared minus 8x squared, which will be minus 35x squared, plus 138x plus 2x, which will be equal to 140x minus 35. Now again, first term minus 35x squared divided by x squared, you get minus 35. You got a number, that means the next step is your remainder. Minus 35. Whenever you have the same powers, if the same powers get cancelled, then in the next step, you always get the remainder. Minus 35 multiplied by the whole g of x, minus 35x square, minus 35 into 4. So you have to multiply minus 35 into minus 4. इसको शॉर्टकट में कैसे करेंगे? Minus 35 into minus 2. So minus minus gets plus into 2. Multiplication by 2 is double the value. So 35 for double 30, you get 70. 70 into 2 is 140. Instead of multiplying it one on one, it's better to use your logic. Plus 140x minus 35 plus 1 is minus 35. Subtraction, sign change. If you can observe, all the three values get cancelled and you get a remainder which is 0 here. Okay, you should get 0 by default because you know that the result that you're getting is g of x. That means you're not getting a remainder along with it, you're getting an exact value, and the result that you're getting is 0 of the given polynomial. So the remainder by default should be 0. So once you got the remainder 0, what's your job? This is your quotient. This is your quotient. This is your g of x. Instead of g of x, because we denote g of x by divisor, let's denote it by q of x, just to avoid any confusion. So I'm writing q of x over here, same as this, q of x over here, all these three bases. So this is your required q of x. And q of x is equals to x squared minus 2x minus 35. Now you can use middle term splitting method over here. This minus 35 is to be split into a difference of 2. So 35 is 7 into 5. You can subtract them to get 2, but you want minus sign over here. So this is x squared minus 7x plus 5x minus 35. This is equal to x common x minus 7 plus 5 common x minus 7. This is x minus 7 into x minus x plus 5. So equating them with 0, x minus 7 is equals to 0 will give you x is equals to 7, and x plus 5 is equals to 0 will give you x is equals to minus 5. So these are your values. X is equals to 7 and x is equals to minus 5, the required zeros. Okay. Next question. If the polynomial is divided by another polynomial, the remainder comes out to be x plus a. Find k and a. K is a variable, k is a constant of the second polynomial. You're dividing the first polynomial with the second polynomial, which means the given second polynomial is the value of your g of x, x squared minus 2x plus k. But a constant k is mentioned over here. Let's see, and you have to find, and the remainder comes around to be x plus a. Your r of x is equals to x plus a. You have to find the values of k and a. K is equals to question mark, a is equals to question mark. Let's divide them. Divide the given p of x, which is x to the power 4 minus 6x cubed plus 16x squared minus 25x plus 10 by g of x, which is x squared minus 2x plus k. So dividing the first value, which means x to the power 4 divided by x squared, you get x squared over here multiplied with the whole g of x squared into x squared, x to the power 4, x squared into minus 2x is minus 2x cubed, x squared into k is plus kx squared. It's okay to solve it in terms of a given variable or unknown variable amidst the expression. Now, what are you left with? Minus 6x cubed plus 2x cubed is minus 4x cubed. plus 16x square minus kx square. You have plus 16x square minus kx square. So you can take x square common and you're left with plus 16 minus k into x square. Other terms mentioned are minus 25x plus 10. Again, the same procedure, minus 4x cubed divided by x square. We're left with minus 4x. Minus 4x. Multiplying this by this, minus 4x cubed. Minus 4 into minus 2, which is plus 8x square. Minus 4x plus k is minus 4kx. Okay. Subtraction, sign change, cancellation. So now you have 16k x square minus 8x square. So this would look like 16 minus k minus 8, taking x square common, and this can further be reduced as 8 minus k into x square. Next, minus 25x plus 4k. So this is minus, taking minus common, 25 minus 4k into x. Given value was minus 25x minus 4 plus 4kx. You took minus sign common and you took wrote x over here. So you're left with 25 minus 4k, which we have written over here, plus 10. Now, dividing again 8 minus k x square with x square. X square gets cancelled. We're left with plus 8 minus k. Multiplying 8 minus k with this, you get 8 minus k into x square. 8 minus k into minus 2x minus 2. 8 minus k into x. 8 minus k into k is plus k into 8 minus k. So let's calculate this. Subtraction, changing the signs. These two terms will get cancelled. Yeah, but what are we getting here? Minus 25 minus 4k. So I'm writing it on the left hand side, minus 25. I'm reducing minus sign over here, so you get minus 25x plus 4kx. Plus, minus got converted into plus 2 into this value. So plus 2 into 8 into x is plus 16x plus minus 2kx minus 2kx is equals to, you'll get minus 25x minus 16x plus minus 25x plus 16x. This is 9x and sign is minus. Plus 4kx minus 2kx is equals to plus 2kx. Taking x common, you get minus 9 plus 2k into x. If I do not take minus common, this is 2k minus 9 into x. Writing this over here, 2k minus 9 into x. What is the second value? Plus 10 minus 8k plus k square. So you have plus k square minus 8k plus 10. Hope this is understood. This is the remainder that you're getting. Let's rewrite the remainder. 2k minus 9 plus k square minus 8k plus 10 minus 8k plus 10. This is your r of x. You're given r of x is equals to x plus a. Given r of x is x plus k. Now what you'll do is you'll equate both of them. This is your first equation, this is your second equation. equating 1 and 2. I forgot to write x. Yeah, this x. There's an x over here. The coefficient of x over here is 2k minus 9, or I'm writing the whole term. That term is equals to xk term. When you equate such kind of expressions, then the variable terms get equated and the constant terms get equated, or the respective like terms, variable terms get equated. Yeah, but x की power is 1 in both these terms, this term and this term. So both these terms will be equated separately. X gets cancelled and 2k minus 9 becomes equal to 1. 9 gets shifted over here and you get 2k is equals to 1 plus 9, which is equals to 10. K is equals to 10 by 2, which is equals to 5. The second value is k square minus 8k plus 10. This value is equated with the constant a. If you substitute k is equals to 5 in here, 25 minus 8 into 5 plus 10 is equals to a. 25 plus 10 is 35 minus 40 is equals to a, which means a is equals to minus 5. These are the values of k and a required. Okay, so this ends this exercise. I hope everyone understood it. If you have any doubts, you can ask me in the comments below. Thank you.